Camera's on. Here we go. Welcome to AP Calculus. We are looking at problem 45 on the homework due today. And I've got the solution right here. My first move was to use the base change formula that I shared with you yesterday. Instead of log base 5, I wanted to change it to base E. So I made it log base E of the input over log base E of 5. Then I made two moves. I brought the 1 over natural log 5 out front, just tagging along for the ride. The derivative process has no effect on this passenger. It's just kind of like someone who's hops into the car for the President's Day celebration out in South Dakota. You know how it is. School's over on Friday. You want to go to Mount Rushmore to celebrate President's Day. And natural log 5 says, I want to come along, so just comes along for the ride. Nothing really is happening to natural log 5 down here. It just comes out front along with the 1/2. 1/2 comes down front because of exponent rules. So when it comes time to take the derivative, we just take the derivative of natural log blob. The derivative of natural log blob is 1 over blob times the derivative of the blob. The rest comes along for the ride. So does that answer your question then? On that, we're okay. Any other questions on the homework due today? 65? All right, thank you for asking. We do have a question on number 65. So far, these are the same questions that were asked in my 4th period class. Yep, 4th period asked about 65 also. So why might this one be confusing? Well, yeah. Get the door here. Just to first of all give you a talk through on this. Look how nicely this problem unfolds if you decide to let u equal 1 plus 3 to the 2x. In that case, du would be 3 to the 2x natural log 3 times the derivative of 2x dx. Compared to what we have, we've got the 3 to the 2x. We don't have the natural log 9. Keep in mind that natural log 3 times 2 is natural log 9. Here's how I explained it to my 4th period class. Natural log 3 times 2, because this is where the question was. That's the same thing as 2 natural log 3. And using exponent rules, that becomes natural log 9. Is that the part that was confusing? Or was it something else? We're just using that exponent rule for logs in reverse to get natural log 9. Is there anything else I can explain on this one, or are we good to go? Jason, or you just want to take some more time, or does that answer your question?
So, like, how do you know you say u equals 1 plus 3 to...
Yeah,
I said,
so,
like, u equal to 3 to the 2x. I don't know.
So, are you asking, why did I let u equal 1 plus 3 to the 2x instead of something smaller, like just 3 to the 2x?
Yeah, is that why they...
Yeah, okay, so thanks for asking that. The process of deciding what to let u equal in a u substitution problem has an element of trial and error to it. Suppose we had let u equal the shorter expression, the slightly smaller expression, if you will, just u to the 3x, in which case du would have been 3 to the 2x ln 3 times 2 dx. Well, that would have given us the antiderivative of, having doctored this up with natural log 9, 1 over natural log 9, antiderivative of 1 over 1 plus u du. Now compare that to mine, compare yours to mine. Mine's a little less complicated because I don't need a w substitution. Yours needs a w substitution because you have to go a step further and say, well, let's let w equal 1 plus u, dw equals du, which you can do. You'll end up with the same answer when all is said and done. But my selection of u avoids having to do an additional substitution. So, you know, over the weeks and months preparing for the AP test, hopefully you'll just get better at anticipating what the best use substitution will be. There's a trial and error element to it. What other questions would you like to ask about the homework due today? By the way, I hope you do finish the homework before leaving for the Black Hills. Promises to be a really exciting President's Day weekend celebration. Just a few miles from here. Last call for questions on the homework due today. All right. Well, hey, let's move on to the lesson for 5.5. We take our journey back to front for Unit 5. I'm going to just pause here for a second while I give you the handouts, and then we'll resume. Well, good afternoon and welcome back. My name is Mr. Royce. I'll be your AP Calculus AB teacher for the afternoon. Thanks for coming out today on this sunny summer afternoon. Now, we're going to learn about a topic that, for me, derivatives of inverse functions, of all the things I had to learn to get ready for this course, it was the last thing I finally learned. It's like, oh boy, this is a tough one. Now, I mention that because I think you'll find that this is a little more challenging than most. This lesson is a little more challenging. Now, how can it be, Mr. Royce, that you had to learn stuff? Well, when I first started teaching AP Calculus, it had been, the first year I did it, it had been 12 years between when I took calculus in college and when I started teaching calculus. So I had to learn stuff because I'd forgotten it. And I remember that derivatives of inverse functions was the last thing, your friends have one, was the last thing that I had to learn. It took a while. There are some levels of complexity in this topic that were difficult hurdles to clear. So you're going to have to take your effort level up a few notches to get ready for today's lesson. I want to share with you some of the things that made this tough wrestling match. Hopefully my struggles will be for your benefit. Stuff isn't easy, but I think as long as you're willing to put the G in vegan tomorrow, then you'll find this stuff really quite understandable and perhaps even enjoyable. But that's a tall order, because as you and I both know very well, you are like many advanced math students across the globe who would prefer that graphs not be a thing. Can you relate to the advanced level math student who wishes that it was really just about numbers and letters in math and no pictures required, no graphs? Is there anyone, I won't call out her name, but is there anyone who kind of feels like that, maybe yourself? Well, today you may have increased affection for graphical understandings of mathematics, because I think they're really the key to helping you understand some of the complexities of taking derivatives of inverse functions. So let's launch into this. Problem 6 asks us to do 4 things. A, answer the question, are f and g inverses of each other? Yes or no question. Do this analytically and graphically. Part C, find the slopes at 1, 15 and 15, 1. And then write the general derivative of an inverse theorem 2 different ways. Okay, so here we go. Part A is a pre-calculus question. No calculus here. They're asking us the question, yes or no, are f and g inverses of each other? Back in pre-calculus, even though I wasn't there in the room when you were studying pre-calculus, I really believe that you were taught to answer this question by examining 2 sub-questions. 1, f of g of x equals x, question mark. Is f of g of x equal to x? And the second question you were taught to examine was, is g of f of x equal to x? That's question mark. Does f undo G? And does G undo F? It's a somewhat tough lesson because the teacher has to come up with examples of situations where F does undo G, but G does not undo F, just to show you that it really is necessary to ask both questions. And if you get a yes to both questions, then you can finally conclude that F and G are inverses of each other. Got to do it both ways. However, as we take seriously my call to you to possibly increase your affection for graphs, I want to do part B first. I want to look at it graphically because the non-graphical approach takes a lot of time. You might actually like the graphical approach. Leave about this much space on the paper just to give you a feel for how much space I'm leaving. There it is. There's fit to heights. Okay. Look, the graphical approach is shorter and more enjoyable. You see, let's look at the graphs of F and G superimposed on the same pair of axes. Notice the equation for f of x is 16 minus x squared with a restriction on the domain x is greater than or equal to 0. Now, check out my arms. They're going to represent graphs. I'm not going to make you stand up and do the dance, but this is x squared, negative x squared, x squared, negative x squared, and then negative x squared plus 16. I'm going up 16. It's like a parabola. It is a parabola, but it's only the right half of a parabola with a y-intercept at 16. Isn't that what the graph of the, I guess you could call it a semi-parabola, would look like? It's the right half of a parabola. Why only the right half? It's because of that domain restriction. X is greater than or equal to 0. And this half parabola, since 16 minus x squared, 4 squared is 16, so the x-intercept must be 4. Okay, so that's the graph of F. And the graph of G is square root 16 minus x. Now, I'll admit that I understand this is part of why you don't like graphs, because when it comes time to sketch the graph of the square root of 16 minus x, you start to feel it's kind of like car sickness. Like, are we there yet? When are we going to get to Mount Rushmore? Oh, I don't want to be in this car anymore. How am I going to figure out what is this? Does it reflect over the x-axis, the y-axis? Do I shift left or right? What do I do with this? Would you agree that sketching the graph of the square root of 16 minus x seems like it's a little mind-boggling? Is there anyone willing to agree? It's like, oh, I'm not sure I see it in my head. I'm not sure I see that, just like that negative sign. It's like, I mean, if it were just x minus 16, yeah, x minus 16, just shift it 16 to the right. How many of you are willing to admit, not on camera, but in front of your peers, that it's not the easiest graph to quickly visualize? Well, thank you so much for your kind transparency, for admitting. For those of you watching at home, or maybe you're watching in the car on your way home from Mount Rushmore, there were a non-zero number of students who raised their hands and said, yeah, that'd be kind of challenging. Well, you know what? I have a message for you. For those of you who are kind of bewildered, your mind is boggled by the task of sketching the graph of g of x equals 16 minus x, then I have good news for you. To sketch the graph of square root of 16 minus x can be made really quite manageable by thinking about, and this is a fun thing to think about watching movies in reverse. Now, earlier this year, didn't we think about movies going backwards? We talked about Heimlich maneuver. Is that one we thought about? You know, forwards, if you're watching a video of someone getting the Heimlich maneuver forwards, it'd be like, oh, no, I'm choking, and then someone comes up behind them and the chicken flies across the room. If you were to watch that video in reverse, it would start out by someone feeling really relieved, it's like, yes. And then all of a sudden the chicken flies across the room, they catch it with their throat, and the end of the video is really quite stressful. I would like you to imagine this function as really being two video screens. It's a double feature. In fact, better yet, let's think of this as the letter Y. I'm here to take the stress out of sketching graphs. There's two videos. We can call it the blue video and the orange video. And they're videos that we want to watch in reverse. You see, this purple function, square root of 16 minus x, is a child of the y equals square root of x parent graph. It's one of the 50 parent graphs we ask you to master. This parent graph has key points x parent, comma y parent at 0, comma 0, 1, comma 1, the square root of 4 is 2. What does this equation say is the linear transformation that turns purple, or turns the parent graph into this purple child function, whose coordinates are x child, comma y child? There is actually a pair of linear transformation equations. Of course, to do this, you would never have to write these down. This is just what's in your mind. You know 0, 0, 1, 1, 4, comma 2 is on the parent graph. How would you quickly find 3 corresponding points on the child graph? Friends, there are linear transformation equations, x child equals y child equals, that gives you a formula for what to do to x parent and y parent to get x child and y child. What has to be done? To answer the question of how do x parent, y parent transform to x child, y child, watch the blue movie backwards. Now, if you were to watch it forwards, the scenes in the movie would be guided by the order of operations. The movie going forwards is plus negative. Multiply by -1, add 16. Imagine you're watching a movie where the first scene is multiply by -1, and the second scene is add 16. Now imagine watching that movie in reverse. Can someone describe what those two scenes would appear to be? Forwards, it's multiply by -1, add 16. What would it be backwards? I'm just going to wait here patiently until someone imagines and articulates what the backwards movie would be like to watch.
X plus 6.
Say that one more time.
X plus 6.
No, I don't want an expression. I want a description of a movie. Watching it forwards would be, well, the first thing it would be multiply by -1, second thing, add 16. No x's. Just, if you were to put something in for x here, if you put a 10 in for x, you would multiply it by -1 and then add 16. That's going forwards. What would the process be backwards? Can someone tell me what the video would be? If you can tell me distinctly what the two parts of the movie would be if you were to watch it backwards, then please raise your hand. Go ahead.
Divide by -1 and add and subtract 16.
Okay, you're close. You said divide by -1, subtract 16. You did the inverse operations, but you did not reverse the order. Remember, if you're going to watch Heimlich maneuver backwards, it goes forwards, it goes choking, and then the chicken flies. So if you're going to watch it backwards, it's the chicken flies into the throat, and then choking. So, try once again. What would the movie multiply by -1, add 16 be when viewed in reverse?
Subtract 16, divide by -1.
He said, and this is correct, friends, subtract 16, divide by -1. If you can watch movies backwards in your imagination, by the way, watching movies backwards is just a fun metaphor for the mathematical process called take the inverse of a function, which is a little bit of a coincidence that in order to take derivatives of inverse functions, we have to think of this idea of an inverse function watching a movie back. So, by the way, multiply by 1, divide by 1. There's nothing exciting happening. For the y children, you just take the y parents. Oops, yeah. The whole time you're wondering, wait, I thought the square root of 0 was 0. Well, it is. Square root of 0 is 0. So 0, 1, 2. So that's fine. Sorry for confusing you with that silly mistake. Okay, now, to find the triplet of x children, this formula, the one that Matt helped us with, was that for each x parent value, we're going to subtract 16 and divide by -1, okay? So like, for example, 0. 0 minus 16 divided by -1 is 16. Here, try it with 1. Do the subtract 16 divided by -1 routine and tell me what you get. Subtract 16 divided by -1. Don't you get 15? Can someone tell me what x child is that corresponds to x parent equals 4? There you go. It's 4 minus 16 is -12 divided by -1 is 12. Now, this actually suggests something graphically. We would take the parent graph, we would go left 16 and then reflect it over the y-axis. Because when you divide all the x's by -1, you're reflecting over the y-axis. So this actually suggests a graphical process. This speaks to us a message. It says take the parent graph, shift it left 16, and then reflect it over the y-axis, because when you multiply all the y's, or all the x's by -1, that reflects over the y-axis. So if you're looking at this, and you think, oh, go left 16, in fact, probably, my guess is that when you were taught to do this in pre-calc, you had to always factor something out. Like factor this out, make it x minus 16. So, maybe -16. Yeah, and that may have brought up the issue of what order do you do this in? Because if you go left 16 and reflect over the y-axis, you get something different than if you reflect over the y-axis and then go left 16. So the order really does matter here. But yeah, you probably learned to factor out the -1, and then for some reason, you didn't know why, but to reflect first and then shift. To reflect over the y-axis and then go right 16. That's probably the order in which you did it. But I'm recommending that you open your mind to taking the watch the movie backwards approach. Either way you look at it, when you sketch the graph of the square root of 16 minus x, you end up with a graph that has an endpoint at 16, goes off like that. It has 16, 0, 15, 1, and 12, 2, which are the coordinates of the 3 points that we just calculated thanks to Matt's formula. Now, in this graphical approach, we ask ourselves, are green and purple taken together symmetric over the line y equals x? Because if a function and some other function g, if two functions if their graphs are symmetric with respect to the line y equals x, if you fold green over purple, or if you fold green over the line y equals x and you get purple, then green and purple are inverses of each other. And do you see the symmetry in the graphs? So if you can get away to sketch both f and g, and if taken together they are symmetric over the line y equals x, then that's a visual indicator that f and g are inverses of each other. It's not a proof, it's just an indicator. To prove it, you have to do what they're asking for in part A. You have to find f of g of x. What do they mean, f of g of x? They mean f of the square root of 16 minus x. Is that equal to x, question mark? Well, to find out, we'd better follow the f rule. The f rule is to take 16 minus input squared. And in this case, the input is square root of 16 minus x. Does that condense to x? I'll tell you this much, it condenses to 16 minus the quantity 16 minus x, which when you distribute and combine like terms, it's true. The answer is yes. F of g of x is equal to x, But we're not done until we also investigate g of f of x. G of f of x would be g of 16 minus x squared. Now, since I wasn't in the room when you were learning pre-calculus, how many of you are willing to testify, or at least raise your hand to indicate that you remember doing stuff like this in pre-calc? Anyone? Yeah, oh wow, there's a lot of hands up. A lot of you remember this, so go ahead and finish g of f of x. G of f of x. Square root of x squared. Yeah. So here's a little nuance. Most people probably skip this because a lot of people write square root of x squared as x. It's actually absolute value of x. The square root of x squared is not x. The square root of x squared is the absolute value of x, which is plus or minus x. But since we're only taking x values greater than 0 or equal to 0, we ditch the negative sign and get x equals x question mark. Answer is yes. Therefore, the overall answer is yes. Anyway, I'm not going to be upset if you skip the absolute value and the plus or minus lines. That's fine. Okay, so no calculus yet. This has just been pre-calculus review. Any questions on parts A or B? All right, now for the calculus part. And again, this was what? It's surprising. It's surprising. They want you to compare the slope of the tangent line at the point 1, 15 on the green graph to the slope of the tangent line at the point 15, 1 on the purple graph. So 115 on green, compare that to the slope of the tangent line at 15, 1 on purple. We're comparing slopes on two different graphs. And in fact, let's draw them. I'm going to select black to get the slope of the tangent line at the point 1, 15 on f of x. Go ahead and draw it. If you eyeball this, it might help you learn the lesson a little more. It might go more quickly into your long-term memory. Go ahead and draw the tangent line to the green graph at the point 1, 15. Next, again in black, I'm going to draw the tangent line to the purple graph at the point 15, 1. 15, 1. 1, 15. Now, I'm a little bit angry at myself because it kind of looks like they have the same slope. I'm hoping you did a better job of drawing than I did. Because if you do a better job of drawing than I did, then you'll probably be able to see that the slopes are actually not equal. I remember last year when I was teaching this to my Calc BC students, I said, oh, what, the slopes are equal of it. No, they're not equal. Would you like to guess what the relationship is between the slope at 115 to the slope at 15, 115 on f? How does that compare to the slope at 15, 1 on f inverse? We've now shown that g is really f inverse. So I'm going to pause the camera. I'd like you to take a few moments to just guess. No calculations. Guess as to what you would have to do to the slope here to get that slope. It is a mathematical process. See if you can guess as to what it is. Just guess. Pause. Okay, so people have had a chance to just think of what their guess might be. Clearly both slopes are negative, and we're going to calculate it, but I'm just going to pull back the curtain a little bit to let you know that the slope of this line is -2. When you eyeball this, does it look like the slope of this tangent line is closer to being horizontal, closer to 0, or farther away from 0 compared to that one? Closer or farther away? Close. Yeah, it is closer to 0. Would anyone like to just guess what it is?
-1.
I've heard a guess of -1. It's not negative. I heard a guess of -1/2. It is -1/2. It's actually always going to be a reciprocal relationship. Whatever the slope on the tangent line is at x comma a, and for some reason that I don't fully understand, our textbook is going to call the y-coordinate a, so x comma, call it x1 comma a. Then if you know the slope at x1 comma a, then the slope of the tangent line at a comma x1 will be the reciprocal of whatever it is here. They're not equal, but it is reciprocal. Okay, so pause on that. Okay, so here's the formula. You're not going to have to go through all the work. What you're going to actually do is start with the formula. Here's a formula that expresses the reciprocal relationship. If you want to find F inverse prime of A, not of x1, but of A, F inverse prime of A, all you have to do is take the reciprocal of the slope of F at x1. Now, maybe you can see why it is that as a teacher, it took me a while to really wrap my head around this formula. It's because there's an A over here, there's not an A over here, but x1 and A are paired together. It's really the picture that helps you see it. The slope of the tangent line at 1 is the reciprocal of the slope of the tangent line at 15 on the inverse function. Does this seem like a tall hurdle to clear? Do you feel how high this hurdle is?
So this only works in an inverse function?
It only works for inverse functions. So the derivative, basically the slope of the tangent line on the inverse function at 15 at A is going to be equal to the reciprocal of the slope of the tangent line drawn to the original function at x1. Now, to demonstrate that that's true in this case, because we haven't, I just told you it was -2. Let's see if it's really true in this case. We're going to end up, for the sake of time, skipping problem 36. So you can cross it off. Let's just do part C. Let's do part C over here. Let's find the slope. Let's find f prime at 1. And let's compare that. Let's also find f inverse prime at 15 and see if it's true that the relationship between these two numbers is a reciprocal relationship. Okay, what is f prime of x? According to what I know about calculus, if f of x is 16 minus x squared, then f prime of x is -2x. I mean, that feels good. That's just taking a derivative of a binomial, of a polynomial, second degree polynomial. So I wonder if what I told you is true. Is f prime of 1 really -2? Oh, sure enough, -2 times 1 is -2. Okay, so that tells us that the slope of the tangent line at the point 1, 15 on the green graph is -2. And by the way, Matt, what you missed when you stepped out of the room was just the expression of today's formula. This is the formula of the day, that f inverse prime at A is 1 over f prime at x1. Our textbook uses the letter A. Here's f of x. You see, if the input is x1, the output is A. They use A to represent what, if it were up to me, I would have used y1. But they use A to represent the y coordinate. Okay? And the y coordinate on the original function becomes the x coordinate on the inverse function. So that's part of why this is a tall hurdle to clear, is that you have to, someone has to tell you, it's secret knowledge, only the initiated get to find this out, but you've gone through the initiation process, so you are permitted to know the secret. A represents y1. So let's see if it's true. Let's take the derivative of f inverse. What is f inverse anyway? F inverse is, let's see, f inverse of x is that g function, the square root of 16 minus x. Would you use what you know about calculus to find the derivative of f inverse? Go ahead and take a few moments. When you're done, look up here to see if we agree. new notation, f inverse prime of x. Did you write 1/2 blob to the -1/2 times the derivative of the blob? Did you remember the chain rule? Times -1. Yeah, so it's -1/2. So let's see if it's true. What is f inverse prime of 15? Or of A in general, f inverse prime of A, which is the y coordinate. Well, to find out, we put a 15 in. Is it really going to be the reciprocal? 16 minus 15 is 1. What's the square root of 1? It's 1. It's true. It's -2 and -1/2. So really, today's lesson is that if you want to get the answer the fast way, just take the reciprocal of the derivative at x1. That's how you get the derivative of the inverse at y1, or at A on the inverse function, A on the inverse. So let's do a sample problem. Let's go to page 2 and try this one right here. Here they're asking us to find f inverse prime of A. Well, this is similar to what happens on the AP test. And if I were coaching you, as I am, f inverse prime of A, the very first thing I would do in this problem is write the formula. Your answer is going to be 1 over f prime of x1. To find f inverse prime of A, just take 1 over f prime of x1. Oh boy, they told us what A is. They didn't tell us what x1 is. That's kind of stressful. You need to know that A is really y. So that's step 1. Step 2 is to find x1. They told us A, they didn't tell us x1. So we're going to put -11 in for y. We're going to say -11 equals 1/27 times the quantity x to the 5th plus 2x cubed. Okay, this is a pre-calculus problem. And I don't know if your parents ever told you this, but if you multiply 27 times -11, you get -297. This equation becomes x to the 5th plus 2x cubed equals -297. So we have to solve the equation x to the 5th plus 2x cubed plus 297 equals 0. Back in pre-calc, Felinsky taught you the rational zero theorem, that if you want to find the rational zeros, you have to use the P over Q idea, that the candidates for rational zeros are in the form of factors of the constant term divided by factors of the lead coefficient. And so, what are the factors of 297? Like 1, -1. Actually, if you add up 2, 9, and 7, you get 18, which is a multiple of 3, so 3 goes in. So 3, -3. So as you're testing this by synthetic division, probably the fourth one you would try would be -3. Is -3 a solution? So 1, 0, x to the 4th, 2x cubed, 0x squared, 0x, 297. When you're going through, you go 1, -3. Synthetic division, -3, 9, 11, -33, 33, 99, and oh, lo and behold, you get -297. The remainder is 0. Score! We found a solution. You know what that means? That means that x1 is -3. We found x1. This means that the point -3, -11 is on the graph of f. So if they want you to find the slope of the tangent line on the inverse, we just take 1 over f prime of -3. Now, the bell might ring, so I might have to keep you 30 seconds over, but we're almost there. So let's bring this to closure. Let's find out what f prime of x is. F prime of x would be 1/27.
Bennett Swanson, please stop in the main office before you leave. Bennett Swanson.
1/27, 5x to the 4th plus 6x squared. And when you plug 6x squared. When you plug -3 in for x, you get, and you have to trust me on this, I hope you believe me, when I say that the answer is 17. This simplifies, when you replace all the x's with -3, you get 17. And therefore, f inverse prime of -11 is its reciprocal, 1/17. So the part I skipped was plugging -3 in for x. You can verify that on your own. Now, the truth is that we're only halfway through the lesson. Therefore, the good news is that instead of having to have your homework done by Tuesday, you don't have to have this assignment 5.5 done until Wednesday. I think you know enough to do the homework, so you could do it over, while you're on the road. You can do the homework while you're driving to Mount Rushmore. Have a good weekend. The homework's due Wednesday. You are dismissed.